Good morning, my dear students. We have the last topic in Unit 5. So today I am going to discuss with you the biogas. All of us are very familiar with the biogas. Before going into detail, let us see what is biodigester. Biodigester is a system that promotes decomposition of organic matter. This produces biogas generated through the process of anaerobic digestion. Biogas generated can be used for cooking, heating, electricity generation, and running a vehicle. What is biogas? You just see the structure, the chemical structure of CH4 is a methane. So biogas is nothing else, it's a mixture of methane and carbon dioxide. So methane is CH4, the chemical structure, and carbon dioxide is CO2. So methane as swamp gas produced naturally in swampy ponds. So biogas is the mixture of gases produced by anaerobic bacterial digestion of organic matter. It consists mainly of methane and CO2 plus traces of some hydrogen and several other gases. This is produced by anaerobic degradation of a variety of organic materials ranging from simple sugars to polymers like nature in the sediments of lakes, ponds, and in rumen of cattle. It is carried out by a man in a variety of reactors called digesters and even in landfill sites under non-septic conditions. So you use the biogas in three ways, that is a direct combustion, generation of electricity, and purification and export as compressed gas or in liquid form. Use of gas for direct combustion close to the site of production is the most economic. This may be used to heat greenhouses, boilers, furnaces, fire brick or cement kilns, for household work like cooking, etc. Alternatively, electricity may be generated by using modified internal combustion engines or gas turbines. The main problems are due to the contaminating gases present in traces which are corrosive to the metal parts of engines. This problem can be partially overcome by cleaning the biogas and by suitable modification of the engine oils. It is used for electricity generation in USA and UK by utilizing the gas generated at landfill sites. Lastly, the gas may be purified and exported via a pipeline as compressed gas or a liquid. The purification process is complex and expensive, but it is being used mainly in USA and in one project in Chile. The purified biogas is used to supplement the existing gas distribution system. So it is produced to the large commercial plants of several thousand cubic meters. You see how this biogas. So it can also be captured from landfill sites where organic waste has been rotting under the ground. You see near outside of our towns and they throw all the waste. No, so these landfill sites also can be used for the biogas. And what are the things that are necessary in this production is the substrate. So the substrate usually employed for biogas generation is a waste product of industrial, can be agriculture, animal husbandry, that means the cow dung, or domestic and municipal origin. Therefore, the waste would contain a variable proportion of non-biodegradable matter in form of plastics, inorganic materials, etc. Lignin is virtually non-degradable under anaerobic conditions. So generally the wastes are divided on the basis of their organic dry matter of a total solid content into the following four categories: the low, the medium, the high and the solid. The decision of a digester design will depend mainly on whether the waste is completely soluble or it has particulate matter as well. So the waste may generate mainly from three main sources, that is the industrial and food processing waste. So these arise from sugar, potato, vegetable and fruit processing, brewery and distillery waste, and as way from cheese production. These are also usually non-particulate medium to high strength waste. The second source is animal, etc. and agriculture waste. These are solid wastes rich in cellulose and lignocelluloses. Etc. from ruminating animals are richer in lignocellulose and less favorable for anaerobic digestion than that of non-ruminants. In India, cow dung is widely used to produce biogas, locally called as the gobar gas. And the third source is the domestic and municipal waste. These are in the form of solid waste and sewage respectively. In many cases, domestic solid waste are used to fill large pits. The sewage sludge is separated by settling down and is digested anaerobically. The biogas so obtained is used to generate electricity for operating the sewage treatment plants. In any case, the waste must contain adequate of other nutrients to support the microorganisms' growth. If needed, phosphorus, nitrogen and trace elements should be added to the substrate. The second is the digester. So the digester design will mainly depend on the type of waste to be handled and the level of operation, that is the small, rural or large industrial operations. The various types of digesters used for anaerobic digestion are briefly described below. The digester may be run in a batch or continuous mode, the latter more desirable for large-scale operations. So in that we see the first one, low technology digesters. These digesters are simple in design and consist of the following. They have a digester, a tank for preparation of the substrate for feeding the digester, and an effluent transfer tank and a biogas storage tank. Various designs of low-cost digesters have been developed, and often the biogas storage tank is combined with a digester. An example for such digester is the gobar gas plant designed to produce biogas from cow dung. Let us see the gobar gas plant. This plant consists of an underground circular pit lined with a cemented brick wall which serves as the digester. The pit is covered with an inverted and vertically movable metal tank, perhaps closed on top, open at the bottom, which serves as a biogas storage tank. A tank is made from bricks on a raised platform above the ground. This serves as a cow dung mixing tank to feed the digester through the inlet pipe and delivers the cow dung slurry near the bottom of the digester. The spent cow dung slurry is removed to a drying bed and is ultimately used as a manure. The gas flows out through an outlet pipe which has a provision of drainage of the excess moisture. So this is the gobar gas plant. We have in the convent, we use the gobar gas for cooking purpose. We have a gobar gas plant here. So next is I told you it is a batch digesters or continuous. So batch digesters are suited for digestion of solid waste, where hydrolysis occurs in a solid waste bed, and the leach aid is circulated through a methanogenic digester and back over the series of such reactors. This can be used for large-scale production. The wells may be vertical or short horizontal, short vertical or bell-shaped. The valves are made up of a perforated or a slotted pipes. The wells are interconnected by pipes and the gas is taken to gas pump or a compressor. The gas is chilled to remove the moisture from it. The gas is then filtered and analyzed before use. Third is the continuous flow stirred tank digesters. So these digesters are continuously fed as well as stirred to achieve a very high mixing. The spent substrate is also continuously removed. They are suited to treat medium to high strength solid waste. Here mixing is done mechanically by a recirculation of the gas. Gas may be collected in a separate tank or the digester itself may have a floating roof. These are the most common type of digesters which are used for sewage and animal etc. treatment. That is the batch and the continuous one. Fourth is a plug flow type of digesters. So these are tubular digesters without any stirring device. Mixing however does occur due to the gas formation. Such as digesters suffer from circumformation, especially in digesters having a large diameters. And the fifth type is the upflowed anaerobic sludge blanket digesters. In such digesters, the liquid waste flows through a blanket of sludge consisting of the bacteria settled as granules of about 4 mm in diameter. These digesters are suited to treat low-strength soluble waste, example sugar beet washings. So the last one is the film reactors. So these reactors contain a support for attachment of the bacterial cells to avoid their washout due to higher waste flow rates. The support may be in the form of a stationary material, that is the inner solids like gravel, PVC supports, glass beads, etc. This forms an anaerobic filter through which the waste passes and is degraded. These digesters have been used to treat vegetable processing waste of medium to high strength and animal waste. They have the problem of clogging and channeling in the filter. So what are the microorganisms? Several hundred species of microorganisms are involved in the anaerobic digestion and biogas production. These substrate bacteria can be divided into the four following trophic groups: hydrolytic and fermentive bacteria, cenotropic hydrogen-producing bacteria, methanogenic bacteria, and acetogenic bacteria. What is the hydrolytic and fermentive bacteria? This group includes both obligative as well as the facultative anaerobes, may occur up to of a sewage sludge digesters. These remove the small amounts of oxygen present and create anaerobic conditions. Bacteria hydrolyze and ferment the organic materials. Digestion of complex polysaccharides is rate limiting, and the lignin associated with cellulose often shields the latter from enzyme action. The second is the syntropic hydrogen producing bacteria. These are also called obligative hydrogen producing or obligative proton reducing bacteria. Here they oxidize NADH by reducing H plus to H2 and thereby produce hydrogen. These bacteria break down organic acids having greater than 2 carbon atoms in their chain to produce acetate, CO2 and hydrogen. They are able to grow freely and produce hydrogen only under low hydrogen partial pressure, which is maintained by methanogens. And the third bacteria is the methanogenic bacteria. This converts acetate and CO2 into hydrogen into methane. Thus, methanogens remove the hydrogen produced by obligative hydrogen producing bacteria, thereby lowering the hydrogen partial and enabling the latter to continue producing hydrogen. The last is the bacteria acetogenic. These bacteria oxidize hydrogen by reducing CO2 acetic acid, which is then used up by methanogens to regenerate methane, carbon dioxide and hydrogen. Thus, acetogenic bacteria also removes hydrogen, and this enables hydrogen producing bacteria to continue their function. I hope you understood the four types of microorganisms which are involved in the biogas production. So the process of biogas production is explained using gobar gas as an example. These gobar gas plants are based on etc. of cattle and other farm animals, which contains about 20% inorganic particles or rajkans. The level of dust particle is reduced to about 10% by mixing the dung with water in 1:1 ratio. So in addition to cow dung, human etc. and kitchen waste also can be used. The optimal temperature for biogas production between 35 to 38. Low temperature lead to the low gas yields. So biogas production during winters and in cold regions requires thermal insulation and heating of the digesters. pH is usually 7. So what are the factors which are affecting the biogas? Depends on the type of waste, temperature during digester operation, the retention time and the presence of inhibitors. The second is the maximum possible gas yield on a complete digestion of carbohydrates would be 0.8 for fatty acids, and this value is about 1.5, but the organic conversion is almost incomplete. Generally, mesophilic fermentation at about 35 degrees centigrade gives the maximum gas yields, while thermophilic bacteria give best yields around 55. Gas yields increase with retention time since a greater proportion of the organic matter will be digested. Agriculture waste, specifically pig, chicken manure, generate high levels of ammonia which may inhibit biogas production. In addition, antibiotics may be used in animal feed and detergents. Anaerobic digestion is mainly used for population control, but its use as an energy source also is important. Certain precautions should be taken while producing the biogas. Organic overloading of the digester should be avoided. Adequate provision for moisture should be made, especially in case of landfilling sites. Adequate nutrients should be present in the waste to support good bacterial growths. In the conditions necessary, the formation of anaerobic fill should be provided. Advantages of this: the technology is very cheaper and much simpler than those for other biofuels, and it is deal for small scale applications. Recovery of the product is spontaneous as the gas automatically separates from the substrates. Dilute waste material can be used as substrate. Aseptic conditions are not needed for operation. Any biodegradable matter can be used as substrate, and there is much reduced risk of explosion as compared to pure methane. I hope, dear students, you understood the biogas production. So if you see the application, they are widely used in China, Vietnam, India, and Central and South America, as well as in developing countries. And it can be used to remote farm area to produce biogas from manure and to protect water resources. So what are some keywords which you understand here is gas, greenhouse, anaerobic, electricity, methane, organic waste. You see how the biogas stove they are cooking. So it is used for cooking purpose, for transport, for lighting. So biogas is made for fermenting organic waste in a biogas digester, and this is a small digester. As I spoke to you about continuous or batch fed digesters. So hope you understood, dear students. Please take the notes. Whatever is explained in the slides is the notes. I have each and every word I have typed. Kindly make use of it.